I brought in this worksheet I created. Motion of a particle along a line. You see, we're going to be given the position function of this, which is what you guys see here. Let the function below be the position function, s and t in meters, and the variable t be in seconds. Determine the velocity function we already did and where the particle stops. So they want us to know, where does a particle stop? Where does it move to the what? In the positive direction. And where does it move in the what? Negative direction. So this is going to help answer some of the questions, that I just remarked on. How did that particle, if it's moving to the left, ultimately get to a position to the right? It has to stop and go to the right now. That's all. We have to know a complete picture of this to draw these pictures. So what I did here is, this is really the curve t cubed minus 6t squared plus 9t for t being greater than or equal to 0. I just want you guys to see on this particular curve, okay, don't you have a horizontal tangent? And isn't it at 1? So I know s prime of 1 equals what? 0. You see this picture over here? Don't you have an horizontal tangent at 3? Yes. That means s prime of 3 equals what? 0. And I can get a lot of information by looking at this curve, but they don't always give you curves. Mr. Judge does, because I want you guys to make the connection with everything to see that the process is just being duplicated again. So geometrically speaking, you're finding the velocity is 0 at those horizontal tangents. That's what that is. And then there's other meaning of this curve. You're going to see that here. But what's the title of this here? Let's put this to work for us. When they're talking motion of a particle, and they just said sign analysis on the first derivative, what does that even mean? That's going to give you all the information you guys need. Because you're not given a curve. What are you given? Just the position function. So they're just going to give you a position function now. We got to perform what? Sign analysis on the first derivative. So, and of course, it's going to be for t being positive. So yes, what was the first derivative anyway? Do you guys remember? Wasn't it 3t squared minus what? 18t plus 9? Is that true? 3t squared minus 12t, sorry. Okay. So, s prime of t, 3t squared minus 12t plus 9. What do I have to do with this? Sign what? Analysis. Okay, now, does anybody know how do you start sign analysis? Always. The first step of sign analysis is you take that polynomial and you set it equal to what? 0. And you want to solve for what? You solve for t. However, how do you solve for t here? Because what I'm saying is you're taking this function right here, set it equal to 0. It's setting that equal to 0 is going to tell you where it stops, by the way. How do we do this? You guys know? Maybe by factoring. You got two options. You can factor, or you can use the quadratic formula. And what does this imply? It implies 2t squared minus 4t plus 3 equals 0. Did I give you guys a worksheet on how to solve quadratics? I think I did. Did I give you guys a worksheet on how to factor? I think I did. There was a reason why I did that. T. I think this is 3, this is 1. I think they're both negative. Is that right? And then you use the zero product rule. Is that true? What is the zero product rule? It means t minus 3 is 0. It means t minus 1 is 0. Solve for t. At t is 3 and t is 1. What do we know about this? What does this tell us? It tells us a lot. This is where this function equals what? 0. And you say, what function? S prime t. So S prime t, which is the velocity, that equals 0 at these locations. This is where your particle has what? Stopped at these two values. But we already know that. Is that true? We knew that by looking at the graph. We knew that. In fact, there's a lot we can see by this graph. But they don't always give us the graph. We're supposed to be doing what? Sign analysis. Now, let's do the second part. The second part is where you partition the real number line. Is that true? Do you guys remember sign analysis from what class? When did you guys do sign analysis? You guys want to tell me? Did you do sign analysis in pre-calculus or intermediate algebra or both? Both. You did it in intermediate algebra, you did it in pre-calculus. Well, it's back, and this time this is going to be, this is that first derivative, S prime t or v of t. When I do my sign analysis, you guys remember it works this way here, right? You partition the real number line, you'll get 1, 2, what? 3 regions. Is that true? Okay, now what do you guys do here? Anybody want to tell me? We have to test the sign of S prime of t. What's S prime t? I'm going to put it together this way. It is 3, t minus 3, t minus 1. I'm going to give you guys the factored version. Yes, I know already. You say, hey, isn't this the function? Yes, it is. I'll bring it down. I use the factored version. We got to check the signs because this is sign analysis. We got to find where this S prime is positive and negative now. But be careful. How do you do that? Do you guys remember how to do that? You need some test points, right? What's the test points? Be careful here, though. This is your t. T starts at 0. So for region 1, I'm going to use 1/2 as a test point. Region 2, I'm going to use 2 as a test point. Region 3, I'm going to use 5 as a test point because I already have all those values from the past work we did. I already know what they are. I just don't know what they are. I don't know what 1/2 is, though, but these are test points, okay? So we have to test t as being 1/2 here, right? We got to test region 1 for the sign. So plug in, you're trying to find this 1/2. The reason I like the factored version is because I really don't have to do much arithmetic. You see, what's 1/2 minus 3? We don't care, but it's negative. Is that true? What is 1/2 minus 1? I don't care, but it's what again? It's also negative. What's a negative times a negative times that 3, which is positive, by the way? This is a positive number. Isn't the answer positive? So all I care about is to say that this region here is what? That's positive. Okay, you guys good with that one? What's the test point for region 2? We got to test the sign of region 2. Maybe you guys like this approach. We say 3 times 2 minus 3, 2 minus 1. Well, I know that's negative 1. That's positive 1. What's the sign going to be here? Isn't that negative? I don't care about the answer. I care about the sign. Region 2 is negative, ladies and gentlemen. All right, good. We got to test the sign of region number 3 now, which we use 5 as a test point. So S prime now of 5 is 3, 5 minus 3, and 5 minus 1, which is, this is 2 and this is 4. What do I know about region 3? We don't care about the value. We only care about the what? The sign. This is sign analysis. So this is going to be positive here. All right. This has all the information we need. We know when the particle is stopped. The particle is stopped when the velocity is 0. The particle is moving to the right when the velocity is positive. It's moving to the left when the velocity is negative. So what colors did we use? I'm going to say positive is green. Okay. This is where you're going to the right for those time values. Where you're going to the left is for these time values. So right, and then what? Left. So that's what they're going to want to know. They're going to want to know, hey, tell me where the particle stops. When does it move to the right, and when does it move to the left? You're doing sign analysis on that first derivative. And that is it, ladies and gentlemen. So if you're, it's kind of something that where my daughter even asked me, Dad, how do you answer these kind of questions? I just look at it and go, oh, sign analysis on the first derivative. Pass the salt now. So I let her go now, get the first derivative and do sign analysis. Yes. Say it again? Well, here's your answer. Let's give the answer here. The particle stops. Where does the particle stop? When t equals what? 1 and t equals 3. Is that true? You're going to give the interval notation. Particle moves to the right. And you want to give that interval notation here. Be careful here. This is from 0 to 1. Okay? 0 to 1. So you say, okay, here's from 0 to 1. This is an open union. It's going to now be 3 to what? 3 to infinity. Yeah, 3 to infinity. So you're going to give the interval here. Okay. And then you say, when does a particle move to the left? Well, that's the orange. They want the interval notation. It's from 1 to what? 3. Do you include 1 and 3? No, you can't include 1 or 3. Why? Yeah, don't. It has to be. What does open mean? Do not include the values. You see, being negative is different than being 0. That's where people make the mistake right here. They go, oh, it's from 1 to 3. Include 1 to 3. No. At 1 second, okay, the velocity is 0. It's not positive. 0 isn't positive. It's not negative. So it's going to be here, open circle. Here, open circle, bracket. Open circle, and then that goes on forever. That's an open circle. So I want you guys to see that in that picture. But the key is sign analysis. And I'm going to remark here, and this is how you guys want to answer those questions here. And what you guys are looking at right here, what do you guys want to call this here? You got S of t being t over 1 plus t squared for positive values of t. Remember what we said. This is a what? A position function represented by the letter S. All right. And what are the kind of things that they want you to do with this function? Is essentially, this is the motion of a particle. They want you to do really what's called sign analysis on the first derivative to really cut to the chase. And you might say, why? Because they want you to determine when the particle stops. We should say when here. Let me correct this here. When the particle stops, when it moves to the what? To the positive direction, or when it's, that means right or up. Sometimes they call that forward as well. When it moves to the negative direction, all right, they call that left or down or backwards, you know. So that's what they want you to do with all these functions. So to make a long story short, you got to do sign analysis on that first derivative because the velocity function, ladies and gentlemen, is S prime t. That's your velocity. This is what we're doing. Sign analysis on that first derivative. All right. And of course, I have the nice graphs there for you to see. I could go back and talk a little bit about it, but let's get started here. We got to first get the velocity function here, which is the derivative of the position function. So we can say v of t is d dt of the position function, which is t over 1 plus t squared. Now, and yes, your t value is greater than or equal to 0. That's a time value. So what rule do you guys use here? Do you guys remember? We should remember we got to use here now quotient rule here. Okay, you're getting that first derivative. So it's done by quotient rule. So we're going to take that denominator function, 1 plus t squared, and square it. Bring it right back up here. Differentiate the numerator, t, subtract, bring that out. Derivative of 1 plus now t squared here. Okay, and again, this is s prime of t, which is the velocity function. So now take your derivatives. This is 1. This is what? 2t. So you get 1 plus t squared times 1 minus t times 2t over 1 plus t squared squared. You get 1 plus t squared times 1 minus 2t squared over 1 plus t squared squared. So the velocity function looks like it's 1 minus t squared over 1 plus t squared squared. So double check, ladies and gentlemen. We need more paper there. So S prime t is what you see here. All right. And that's also the velocity function. So You know, you could use either notation. So I just want you guys to know that here. So that's really the first part of what you guys want to do. Is that right? So you need to get this equation. But then now you have to do what on this? Sign analysis, so you can find where, you know, the particle has stopped, when it's moving to the right, when it's moving to the left. Okay, you got to find those things. That's only done by sign analysis on this function. And that's why, you know, they gave you that title. Information in the title of this. All righty. So I want you guys to notice this, that you have a rational function here. Because for sign analysis now, did you guys get that link I sent you guys? You guys want to review sign analysis? That we really take a close look at this, meaning 1 over 2 squared over 1 plus t squared squared. This is your sign analysis procedure. You want to find two locations. Where is the numerator equal to 0 and where is the denominator equal to 0? Okay? So this is what you're really looking to do. You're looking at it as a rational function, like the information I sent you guys. And what that means is I get 1 minus t squared is 0. And I get 1 plus t squared squared is 0. So we want to look at those two. Where's the numerator 0? Where's your denominator 0? Now, this really is t squared equals 1. I'll use intermediate algebra, the square root formula. So t is plus or minus 1. That gives me two solutions. T is positive 1 and t is negative 1. Okay, that's where my numerator is 0. And then I'm going to say, where's the denominator equal to 0? I'm going to use a little bit of some logic. Okay, it's really from algebra. If a squared is 0 or if b, let's use b for base, because that's what you're really looking at. Then that means b must be 0. The base, this is the base they're talking about. So that implies we got 1 plus t squared is 0. Now, what am I going to say about this equation? Do you guys know what I'm going to say about this one? Using algebra, what do we know about this? This never what? That never happens. You can't take 1 plus t squared and have it equal to 0. You say, why does that never happen? Well, it never happens for a real number, because now your t will be imaginary. It's plus or minus the square root of negative 1, just using a little bit of intermediate algebra. And this is a complex number. The point is, this never happens in the world of real numbers, which is what we're looking for, a real number. So this is all good information to use in sign analysis, and that's the key now. All right? So, okay, we're working on sign analysis. What do you do with these numbers? Let me remind you guys here that the t-values can never be negative. They're only positive or 0. So because of that, this also gets what? Thrown out. Because t is greater than or equal to 0. So we can't have a negative number. So when you look to perform all your sign analysis now, just draw your real number line, and you only have, I'm going to put it over here, t being 1 now. This is where the derivative of the function is 0. Remember, this is about s prime t now, or the velocity function. So you might think that you now have really what? Two regions. Well, you actually do. Okay, so that t value where that first derivative is 0, it's 0 when t is 1. But I have to remind you guys here. Notate 0 because region 1 does not include negative t values. T is strictly positive. So you're going to need to have a test point in sign analysis, like probably 1/2. I would use that as a test point. Because remember, you're testing the sign of each region. This is sign analysis. And then 2, you got a test point there. You're testing the sign of each region now. And you say, what am I testing? You're testing this particular function right here. You want the signs of this function. All right. And that's kind of what you're doing here. You want the sign. Hey. All right, let me get the function down there. Is everybody okay at this point here? You guys recognize that process? T is 1/2, T is 2. So let's test each value. When T is 1/2, okay? Notice the arithmetic. I get 1 minus 1/4 because I'm squaring that 1/2. Then I get 1 plus 1/4 and I square that. Notice I don't care about the denominator, only the numerator. Because 1 minus 1/4, isn't that 4/4 minus 1/4? And I'm going to say you get a positive number here over a positive number. And what do I know about the sign? Positive over positive is what? Is positive. So we're showing here when the test point is 1/2, we're really testing region 1, it is positive. Okay, that's good to know. Now let's test region 2, and your test point now is what? Is 2. So use 2 now. And I'd like to remark further that your denominator, we can kind of see, is going to be a positive number, right? 1 plus 2 squared is 4, square that. Number is positive. We don't care about the value. We just care about the sign. But then now here, with our test point being 2, we get 1 minus 4. And, oh, what do we know? That number is what? Negative. Is that right? It's negative 3, by the way. But what's a negative over a positive? What's that going to give you guys? Yeah, region 2 is what? Is negative, ladies and gentlemen. So you have all the information you need to answer the question under sign analysis. Okay? So I want you guys to know, and you go, what do we mean by that? Well, region 1, there's an interval there. Region 2, there's an interval here. And then this information, when T is 1, offers me some important piece of information. Okay? Now you might say, what comes next? What does that mean? It means our conclusion. This is the conclusion. They want to know, when does the particle stop? What would you guys say? The particle stops when the velocity is 0. That happens at T is 1. So particle stop when velocity equals 0, which means T is 1 second. This is the time. This is when the particle stops. Stops at 1 second. They want to know that information. Good. Now, when does the particle move to the what? To the right. Well, in this picture, it's green. And you say, why? Because it moves to the right when that velocity is positive. This is also the positive direction, they call it. Sometimes they call it moving forward, move to the right, move up. Now, when does that actually happen? Well, that's S prime is positive. This is why you did sign analysis. So if I really did a close look at the interval, this is a square bracket and this is an open circle. All right? Now, what does that mean? That's from 0 to 1. So you can say 0 less than or equal to t less than 1, because in interval notation, it's 0 to 1. And this is a parentheses. So I want you guys to know that too. This is a pretty big deal. But a positive velocity means the particle is moving in the positive direction, or moving to the right, or moving up. And MathGTP says moving forward. When is it moving in the negative direction? Well, region 2. Negative direction is also thought of as moving to the left, moving down, or moving backwards. So I have to describe this as an interval. I don't include t as 1. Does anybody know why? Because at 1 second, your velocity equals 0. 0 is not negative. So we need this to be strictly what? Negative. So you're looking at 1 to infinity. So the particle moves to the what? The left when S prime t is negative, which means t is greater than 1 as an interval. It's 1 to infinity. And we colored that orange in this picture here. And, you know, this is the answer that they're looking for here. So here's your conclusion, ladies and gentlemen. So the good news is really this. We already talked and worked on what I would say derivatives. And sign analysis, you look at that process, I should say, in intermediate algebra and then in pre-calculus. So that's the idea. There's an algebra behind all this stuff, as you guys know. So what do you guys think about this? Is that pretty simple? Pretty straightforward, you guys think? Let's make sure there's audio here. All right. Let's do this all again. What about question number 3 here? And let me go back and show you guys a picture here really quick. Remember when t is 1? This curve is your S curve. This is S of t, by the way. Okay? The derivative when t is 1 is actually 0. That's just like asking you your horizontal tangent. You got a horizontal tangent when t is what number? When t is 1. So, you know, it's kind of is to expected, but I just want to let you guys know that there's that geometric relationship between the derivative and what you're doing now here. It's kind of like asking, where's the horizontal tangents? In some way. And you're getting, if they ask you the same question here with this function, hey, where's the horizontal tangents for this? You go, oh, it's the same question. I can tell you there's only going to be one of them. How do I know there's only one? Just looking at this graph, just to kind of share with you guys again, these ideas, okay? Horizontal tangent, okay. So let's go through all the process again. If this is my S of t, V of t, which is S prime of t, I'll show it to you a little bit different. We'll add that. I have to differentiate t cubed minus 12t plus 3, which will be 3t squared minus 12, okay? So my derivative or velocity function is 3t squared minus 12. This is the velocity function. This is what they want us to find, okay? So you guys okay with that derivative? What comes next on this? sine what? Analysis. We got to find where that derivative is 0, which is the velocity being 0. We got to find where the velocity is positive and where the velocity is negative. That's code for just sine analysis. Okay. So your first step, again, is start by letting that function be 0, which is 3t squared minus 12 equals 0. Factor the 3 out because you're solving a quadratic equation. That means t squared minus 4 is 0. You can solve that by factoring, or you can solve it by using the square root formula from intermediate algebra. Use the square root formula. Okay. Now, that means t will be plus or minus the square root of 4, which t is plus or minus 2. All right. So we solved an equation here. And that means two things. T is positive 2. It means t is what? Negative 2. So I already know from experience we got to throw out this other solution because it's what? It's negative. And t is always positive. It's greater than or equal to 0. It could be 0, but it could never be negative because t represents time. You don't go back in time, okay? So this is why they'll always have that kind of statement there for position functions that t needs to be greater than or equal to 0. Okay, easy peasy lemon squeezy. So what does that mean for sine analysis? Well, that's good news for sine analysis. Like before sine analysis. This is about the first derivative. We know at 2, the first derivative is 0. We also know we got to look at t values that are greater than or equal to 0. So we got to throw out the possibility of negative t values. So we have these two regions here. The particle is stopped, ladies and gentlemen, at 2 seconds. Now, this is a nice situation because region 1, we got to test the sign. So we need a test point. It could be any number in region 1. Well, any number other than 2. What's nice is 1. And I use t for test point. I'm going to use that to test region 1. And then I'm going to use maybe 4. I could use 3, just any number to the right. You guys remember sine analysis? Okay. All right. So I got to use the derivative. I'm doing sine analysis on that first derivative. All right. Plug in your test point. 1. This gives you 3 times 1 squared minus 12, which gives you 3 minus 12, or that's negative 9. So what do you guys know about region 1? Looks like region 1 is what? It's negative. Let's test region 2 now. We're going to use 4. So this will give us 3 times 4 squared minus 12, which is 3 times 16 minus 12. 48 minus 12, I think it's probably 36. The point is, region 2 is what now? It's positive here, okay? So, you have all the information you need to start to answer these questions now for sine analysis. You got all that information. Try to do a rectangle. I guess we'll do it like this. We can see this here, okay? So the rest is going to be, can you guys actually read your sine analysis work to write a conclusion with the definitions that we gave you guys. Now, I got to go back to my colors here, okay? So green was positive and moving to the right. So I'm going to kind of use that here. This is where it's positive, negative, okay. When does a particle stop? It stops when that derivative, when the velocity is 0, and that happens when t is what? 2 seconds. When does a particle move to the right? Well, when velocity is positive, and then it's positive for region 2, can we read this? This is an open circle starting at 2. What does that mean? Well, it means for t values that are greater than 2. As an interval notation, in case they give that to you, that's 2 to infinity. Okay, so this is moving to the right, or moving up, or moving in the positive direction, or moving forward. Okay. I'm just sticking with right and left. Move to the left. Well, that's when your derivative is negative. And that's the orange that we see here. And what's the time values here now? Well, you include 0, but you don't include 2. So that's from 0 to 2, but you include 0. So you say, what does that look like? 0 less than or equal to t less than 2. And as interval notation, that's 0 to 2. This is where the particle moves. So if we want to highlight everything, it stops. They want to know the time values. This is what they want to know. What do you guys think? Is that okay? All right. And sure enough, at this graph, yeah, when t is 2, you got a what? Horizontal tangent at t is 2. Slope there will be 0, just on this curve. So this is an application of derivatives. All right. Okay. We're going to look at question number 4 now. We're going to find the velocity function given the position function. So our position function here is t cubed minus 4t squared plus 3, and the time is greater than or equal to 0. So velocity again is the derivative of t cubed minus 4t squared plus 3, which would be 3t squared minus 8t. So we can look at this as s prime t or v of t. Here's your velocity function. And what we're supposed to do with this, again, is we're supposed to perform sign analysis on that first derivative, whichever one you want to look at. It's the same derivative. So we have to do sign analysis here. Okay, sign analysis on that first derivative. So we're going to look at this function here, and remember the first step is to set that function equal to 0 because it's a polynomial function. It's not rational, but either case we set it equal to 0. And now we're going to solve for t here. And solving for t, we're going to factor. We're going to use the greatest common factor. I don't know what happened there, but all right. So here we go. Looks like t comes out only. And you're left with 3t minus 8 equals 0. We got to solve this for t. And solving for t now, you use the zero product rule. This means t is 0, or 3t minus 8 is 0. So we're going to solve for t. 3t is 8. Divide both sides by 3. And now you get t is 8/3 here. Okay. So we have what we need. We have a real number line. This is over the first derivative. And it happens at t is 0, we get 0. And at t is 8/3, we have a 0 for the velocity. And we could look at it this way. This is region 1, region 2, region 3, if we're looking strictly at the sign analysis process. T again is positive. So let's go back and remember we're going to check the sign here of this function. But the t values are positive. Actually greater than or equal to 0. So it means quadrant 1 is thrown out because these are t values that are to the left of 0. And I recommend using in sign analysis the factored form. You guys will see how that can be actually beneficial. So for the sign analysis procedure again, we need to test the signs of each region, really testing the sign of region 2 and region 3. We need test points. So 1 is available. I'm going to use that as a test point. And then 8/3 we're going to use is less than 9/3, which is 3. So we got our test point values 1 and 3. We're going to test the sign of the region by plugging in 1, which gives us 1 times, really 3 times 1, which is 3, minus 8, which really this is just 3 minus 8. I guess we don't need the parentheses. And that's going to be a -5. Now we only care about the sign here, so region 2 is negative. This is how we perform sign analysis. When we test region 3 using that test point of 3 here in the sign analysis procedure, we're going to try to find the sign, which is 3 times 3 minus 8, or 3 times 9 minus 8. It's 3 times 1, which is 3. The point is this is positive here. Okay? Now, okay, here's the sign analysis we're supposed to do. Now remember this is sign analysis, but remember what they want to know with motion. They want to know, when does the particle stop? Well, it stops when your velocity is 0. And that happens when t is 0 and t is 8/3. Those are in seconds now. Okay? This is where your velocity is 0 when t is 0 seconds and t is 8/3 seconds, because this is the whole purpose of us finding those values in sign analysis. Now, your particle moves to the right. We'll say it'll move to the right when that when the velocity is strictly positive. That's why you write greater than 0. The velocity is positive here in region 3. So we want to know, what is that region? Well, that's for time values that are greater than 8/3. That's an open interval. So I'll write it as an interval notation. It goes from 8/3 up to infinity, but we have it described as t being bigger than 8/3. So if t is bigger than 8/3 here, the particle is going to move to the right, and that's the analysis they want us to discuss. Moves to the right for t values greater than 8/3. We'll move to the left now. When velocity is negative. So this is why we did sign analysis again, because region 2, your velocity is negative. Remember, this is at S prime t. We check the signs of that. And the interval notation is going to be from 0 to 8/3. Now, what does that mean in terms of t? We said, okay, t is going to be between 0 and 8/3. So we say 0 less than t less than 8/3 seconds. And this is where your particle will move to the left now. So this is the conclusion for question 4. This is why you did sign analysis on that first derivative. This is describing motion, direction, left, right. When does it stop? And that's what you're looking at for number 4. Okay. We're going to repeat the process for number 5 here. We're going to look at sign analysis on the first derivative, which is the derivative of really the position function, s of t. S of t here is 5t cubed minus 4t squared plus 7 for t values greater than or equal to 0. So we need that derivative again, which is your velocity, s prime t. So let's go through this process. All right. So velocity, which is s prime t, which is the derivative of your position function, which is 5t cubed minus 4t squared plus 7, which becomes 15t squared minus 8t. So we can write that as s prime t or velocity, v of t, doesn't matter. We got the derivative. Now, the sign analysis portion. This is what this looks like. We set the velocity equal to 0 and solve for t. So that would be 15t squared minus 8t equals 0. We got to solve for t now. So this is beginning algebra, and the only way you can solve for t here is by factoring out your t. Then you have 15t minus 8 equals 0. You get t is 0. And 15t minus 8 is 0. We're using the zero product rule. I didn't do this prior, but I want to share that with you guys in case you need to review that. The first solution is done, t is 0, and then the second solution, we got to solve for t. So that would be 15t is 8 by adding 8 to both sides. Now divide both sides by 15. Reduce your fraction if you can. I don't think you can. You're done with that. This is the second time value where your velocity is 0. This is in seconds. In seconds again, let's Let's write it this way, seconds. All right. Notice something here I didn't share with you guys, but these are the t values also where you got these horizontal tangents here. If I can do that, I didn't share with you guys that in the other picture. Okay. This is where t is 0 down here, and I guess this other is going to be, what is that? 8/15 now. Right? So the derivative of the function, this is your s function. Like over here, just to kind of remark, at 0 and 8/3, right? So in this function here, this is s again. This is where t is 0. And it looks like over here is where 8/3 will be. So I just want to kind of go back and give you a little bit of the geometry and how that relates to something you already know and have done. These are the horizontal tangent locations where your derivative at those values of t is 0. So we just want to go back and remind people, horizontal tangents, it's all fitting together. You'll see it over and over again, but all right. Back to our sign analysis. Okay, so we'll draw the real number line, and we'll remember that here's where t is 0. Here's where t is 8/3 for the velocity function. I hate that. Sorry, you guys. I just don't like that weird line. This is where that derivative was 0. And again, you partition the real number line into 3 regions like we've been doing. Come on, seconds, move over there. And we go, okay, here's region 1, region 2, region 3. Your derivative, which we'll test the signs for, is this function, if we can bring it. Okay. But remember, t is greater than or equal to 0. That means we have to throw out region 1. We just need to test region 2 and region 3. So we need test points. And again, 8/3, 8/15, that's, I said there's a little deja vu there, but it's not 8/3. It looks like it's 8/15 here. Okay, that means my first test point, I have number 1 available again as a test point. Yeah, let me check something. Yep, number 1's available. Okay. All right. And what's bigger than 8/15? The number 2. That's available in region 3. So we're going to test the signs of region 2 and region 3. But like I mentioned before, I think that the factored version of your polynomial is a lot easier to do the arithmetic with in terms of using your test points. So for the first question, this is 1. 15 times 1 minus 8. This is just going to give us a 15 minus 8, which is about a positive 7. So region 2 is positive. The particle's moving to the right for values of t in region 2. Consider the test point now of the value 2. So we're going to plug in 2 wherever there's a t. This is sign analysis. This is 2 times 15 times 2 minus 8, which is 2 times 30 minus 8, which is 2 times 22. We get 44. So it looks like ladies and gentlemen, region 3 is also positive. Okay. I don't think we've done anything wrong so far. Actually, we made a mistake. Yes, we did make a mistake. We can't use 1 as a test point, so there is a mistake. I went back. This region, remember, 8/15 is actually smaller than 1. So let's use 8/15. Let's use 1/4. So we made a mistake on that. Okay, that's barely smaller than 8/15. That might not even be that. So let's actually use something very small like 1/10. I think that is definitely smaller than the 8/15. We made a mistake. Let's fix this. 1/10. Okay. And we can do that. Plug in 1/10 now. Wherever there's a t, you get 1/10. 15/10 minus 8, which is 1/10. 15/10 minus 80/10. And that'll be a 1/10 times a negative 65/10. So this answer is negative. I know it's negative 65 over 100, but I don't care about the value. I care about the sign. It's positive times a negative. So this would be a negative answer right in here. Particles moving to the right. Particles moving to the left. Particle stops at 0. So now we have all the sign analysis information we need here, ladies and gentlemen. Let's get rid of the arithmetic. You got a video, you can rewind it, you can take a look at that. We're just going to now look at the solution here. Okay, I'll even get rid of the factored version, but they want to know, when has the particle stopped? Well, the particle stops again when the velocity of the function equals 0. That happens when t is 0 seconds, and that happens when t is 8/15. These are in seconds. Okay. There we go. The particle moves to the right when that velocity function is positive. And that's in green over here. So you're moving to the right for t values. Let's take a look. I like to see the interval. That's open circle because you don't include the 0. Okay, we don't include the 0. That's from 8/15 forever to the right there. So as interval notation, that will be 8/15, comma, infinity. In terms of t, we just say t is bigger than 8/15. So for the time being bigger than 8/15, you'll be moving to the right. You're going to move to the left now. When that derivative is negative. Now, where is that derivative? Negative, right in here. For t values between 0 and 8/15. So 0 up to 8/15 in terms of interval notation, that means your t is between 0 and 8/15. This is the time interval where your particle moves to the left, ladies and gentlemen. So there's your conclusion. I will send this to you all, and it's sign analysis on that first derivative. Okay.